Hello everybody and welcome back to another SAT math video. If you haven't seen on our channel, we've started uploading shorts, so I think what we're going to start doing is doing a main video like every other day and then shorts on the other days. The shorts really do bring a lot of traction to the channel, and I think that'll help us improve our content too, because the more people that view it, the more feedback we'll get. But anyways, today I want to talk about SAT math, and we're going to be doing some practice problems on the category of problem solving and data analysis. So the first skill that we're going to focus on is these ratios, rates, proportional relationships, and units. And you'll see that these are really just like ratios, right? Like miles per hour or something. Because here we have something, okay, a sample of oak has a density of 807 kilograms per cubic meter. The sample is in the shape of a cube where each edge has a length of 0.9 meters. To the nearest whole volume, what is the mass of the cube or the sample? So to find something like this, well, we need to find out what the volume of the cube is, because we have a density that is equal to 807 kilograms per cubic meter. So like this. And to get an answer that's in kilograms, we need to multiply by some number that is a cubic meter. And the way to do this is to find the volume of a shape. Doesn't even have to be a cube, but in this example it is, because the volume is also going to be in cubic units. Now, if we remember, the volume of a cube is just the side length cubed. Side times side times side. So the volume here is going to be 0.9 cubed. So the mass here for our example then is going to be mass equals 807 kilograms over meters cubed times 0.9 cubed meters cubed. Now what does that result with? Well, that leaves us with, let me do it on my calculator, 588.3, so we'll just say 588 kilograms. And you can see that when you do it like this, the meters cubed crosses out and only the kilograms is left. So our answer is going to be A here. Next question, it's going to be also another ratio. The International Space Station orbits Earth at an average speed of 4.76 miles per second. What is the space station's average speed in miles per hour? Well, why don't we try setting up something similar? So let's try 4.76 miles. Let's just use M for miles, or I guess we could do MI, over 1 second. Now, how do we convert this to miles per hour? Well, first what I'm thinking about multiplying by is, well, we know that there are 60 seconds in 1 minute. So what does this leave us with? Well, let's see. This leaves us with 285.6, and then the seconds cancel out, miles per minute. Now, if we do this again, but we say that there's 60 minutes in an hour, well, what do we get? Well, 285.6 times 60 is going to be 1,700 or 17,136 miles per hour, which, as we see, is our answer D. So pretty much you just have to use the knowledge you know. If it's something that's more unknown, they'll probably give it to you. But you kind of just got to convert between the units, and if you set it up like this, it's not hard to get it right, because you see that, well, seconds on the bottom, seconds on the top, they should cancel out. So as long as you do it like that, it shouldn't be that bad. Now the second concept that we're going to be looking at today is two variable data, models, and scatter plots. Now stuff like this doesn't include as much like actual, well, I don't want to say actual math, but like solving something as much as you need to understand something. So here we have a scatter plot that shows a federal mandated minimum wage every 10 years between 1940 and 2010, and a line of best fit is shown, and the equation is given. What is the line of best fit predict about the increase in minimum wage over the 90 or 70-year period? So what I notice is that each of these questions have some period of time each year or each 10 years between 1940 and 2010, the average minimum wage increase, or the average increase in minimum wage was, and then by some amount. Now, immediately, we see that there's this 0.49 or 0.488 thing here. And we also see that that's our mx plus b. That's our b in that equation. And we know that the b doesn't change with time. It's just where the graph starts when x is 0. So since the b doesn't change with time, that's not going to have an effect on the increase in the minimum wage. So we can eliminate b and d. And then what it's really testing us for is, do we know the difference between a and c? Well, with A, it's saying each year the average increase is basically $0.1, and every 10 years the average increase was $0.1. Well, if we look at the graph, we can see that after like 20 years, the value is around $15 or $1.5 per hour. Now, if this was the answer here, well, we could just do some simple math. Basically, let's round it to 0.1. So let's say 0.1 times 15 divided by 10. Now, why are we dividing by 10? Because it's saying every 10 years, and this is 15 years. So we're getting 1.5 sets of 10 years, which leaves us with 0.15. Now, I'm no genius, but I don't think that's equal to 1.5. So likely that's not going to be the answer, but let's just prove that A is the answer. So A, we would have 0.1 times 15 because it's every year. We don't have to divide by 10. And that would be 1.5, which is what we calculated before. So our answer here is going to be A. Hopefully that made sense. And one last question here. So a scatter plot, or the scatter plot, shows the relationship between two variables, and an equation can be written like this. So the standard form of the exponential form graph, where a and b are positive constants. Which of the following is closest to the value of b? Well, immediately what you can sort of notice here is that 3 of these are numbers above 1, and 1 of them is below 1. Now, for this, you kind of got to know how exponential graphs work. If b is above 1, then the graph is going to sort of increase like this. Why? Well, let's say b is 2. Now, as x increases, we have like 2 to the 1, and then 2 to the 2, and 2 to the 3. So that's like 2, 4, 8. And you're multiplying a by that value, and that's increasing. So the graph is going to increase. Now, if b is less than 1, it's kind of going to look similar to the graph here. So we kind of already know what the answer is, but I'll explain. So say that b is 1/2 or 0.5. Now, if x is 1, well, we have 1/2. If it's 2, we have 1 over 2 squared, which is 1/4. If it's 3, then we have 1/8, and it continues like that. Now, what you notice is that you're multiplying a by a smaller value as x increases. And when you multiply a by a smaller value, well, the value that's given is going to decrease. So that's why multiplying by or having a b that is less than 1 leads to a decrease. So our answer here is going to be A. Hopefully that helped you guys. If you have any questions, comments, concerns, please feel free to leave a comment.